All right, guys, welcome back. This is our second to last week doing our fourth 9 weeks for this school year. So we're almost done. All right. So second to last assignment, we're going to be going into the same thing we did last week, determining triangle similarity. This is just going to be more practice on that. Okay, more practice on determining triangle similarity. So I don't have anything really new to show you, so I'm just going to go over 5 more examples so that you guys can get a little bit more practice before you start on this assignment. Okay, so the assignment, it's going to be the same type of problems as last week, just a little more practice. Okay, real quick, I want to make a big announcement. Starting Monday, I'm going to reopen all of the assignments that I've assigned so far this fourth 9 weeks. Okay, all of the assignments, and I'm going to make them all due on Friday, May 22nd at 11:59 p.m. that night. Okay, that's the last day of school. All right. I've been getting a lot of emails, students asking if I can reopen their assignment. Mister, I didn't do the assignment. I didn't finish. A bunch of excuses. So what I'm going to do is just open up everything for everybody, and it'll all be due on May 22nd. Okay. Now, what does that mean? That doesn't mean that if you've already taken the assignment, you've already done the assignment twice, it's not gonna open it up for you a third time. This is just if you haven't attempted the assignment at all, or if you've only attempted the assignment once and you haven't used up your 2. That'll be reopened for you guys. So anything that's been expired, all the due dates are going to be all moved over to May 22nd, the last day of school. Okay. Do not email me after May 22nd with more excuses as to why you couldn't do your assignment. Everything is going to be shut down at 11:59 p.m. May 22nd. I won't even respond to your emails after that at that point. Okay, so I'm just going to deny any requests after 11:59 p.m. on May 22nd. Okay, so with that being said, let's go ahead and get into the examples. These will be fairly simple, 5 examples, one of each of the scenarios. One of them is going to repeat, but that's okay. Okay, so let me go ahead and shrink our screen down here. And let's look at our first example here. Okay, again, I wrote these out here just so that I can do process of elimination of which postulate I'm going to use to prove that these 2 triangles are similar. Okay, so here's our example. We have a small triangle within a bigger triangle. Okay, and again, we're just going to determine, is it going to be AA? Is it going to be SS or SAS? Well, let's go through what exactly we need for each one of these postulates, and then we can determine which one we're going to use. Okay, AA means that we need at least 2 angles that are 2 congruent angles, corresponding congruent angles, to use AA. Now, we do have one angle here that we know for sure is congruent based on the way this picture is drawn. Okay, angle L is the same angle in the small triangle as it is in the big triangle. So automatically we can say, okay, that's one of our congruent angles. All right, but we need a second angle, and you may think or assume that because these 2 angles kind of look alike that they're congruent, and since these 2 look alike, they're congruent also. But the only way we can know for sure is if these 2 lines are parallel, and we don't have the little markings that show that they're parallel. Usually you'll see a little arrow like this, and a little arrow like this. That means that those 2, well, didn't draw them very well, but that means that those 2 lines are parallel. Okay, but since we don't have that right now on the picture, we can't assume that these 2 lines are parallel. So these 2 angles, we don't know if they're congruent. These 2 angles, we don't know if those are also congruent. So we won't be able to use the AA postulate. All right. Side, 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 we need to know all 3 sides to both triangles. Okay. Here we know this side, we know this side, but we don't know the bottoms of the triangles. So we won't be able to use SSS. Okay. SAS, that might be our only option left. To test that, we need to know at least 2 of the sides of both triangles. We'll know the side here in just a bit. We know these 2 sides. And the other stipulation is that the angle that we're going to be using, which is angle L, has to be in geometry what we call included. Okay, I've talked about this before. Included means that it's between the two sides that you're going to be testing. All right. So in this case, L is in between these two sides. So SAS might be a possibility. So let's go ahead and use the SAS postulate to see if we can determine if these two triangles are similar or not. Okay. The A is going to be the angle, which is angle L. And we already know, like we said, that angle L is the same angle for the small triangle as it is for the bigger triangle. So for sure, we have the A already down. We need to test the sides. Okay. To test the sides, we have to check to see if they're proportional, right? If they're equal to each other. And we're going to use fractions or ratios to determine that. Okay. Since I'm only doing two sides, I'm only going to have two fractions. Now, again, I'm going to use the top part to represent one of the triangles and the denominators of the fractions to represent another triangle. Right? You can choose whichever order you want. It's up to you. I like to do things a little, well, in my head, what makes sense or what's logical is going like from left to right, small to big. So in this case, I'm going to go and go from small to big. Okay, so I'll start off with the small triangle. That'll be the numerator, and then the bigger triangle will be the denominator. All right. Okay. So now I need to know the lengths of the sides, two of the sides of the small triangle. I have 10 here, but I don't know what this side is just yet. I know that the full length from J to L is 21, and I know the length from J to K is 6. So to find the length that's missing here, I'm just going to subtract 6 from 21, and that'll give me 15. Okay, so far the small triangle has sides 15 and side 10. All right. Okay. All right, so what I'm going to do is go in ascending order. That's from least to greatest. Again, you can choose whichever order you want. Just make sure you're consistent on the top and on the bottom. To me, it makes sense to go from least to greatest. So the smaller number of the two is going to be 10. The next one, then the bigger number of the two, of course, is going to be 15. So from 10 to 15, that's in ascending order. Now we'll do the same thing, but with the values of the bigger triangle for the denominator. Okay, so the bigger triangle has side 21 and side, well, we don't know what the length of this one is, but we can add them. From L to M is 10, from M to N is 4. So the distance of the whole thing is going to be 14. Okay, so between 21 and 14, their smallest number is going to be 14. So 14 will go here. And then the bigger of the two, of course, is the only other number available, 21. All right. If these two fractions are equivalent or equal to each other, they're proportional, then we can say that this triangle is similar using the SAS postulate. So let's go ahead and do that. All right, again, we're not going to use nsolve because we're not looking for a variable. We're just going to do a simple calculation. Okay. So I'm going to hit N, Control N, add calculator. I think it was already there. Okay, so we'll start with our first fraction. Our first fraction was 10 over 14. 10 over 14. That's going to be equal to 15 over 21. 15 over 21. Okay, hit enter. That's true. So we know that they are proportional because the SAS postulate proves, sorry, not proportional, but yeah, these are proportional, and that proves that these two triangles are similar based on the SAS postulate. Okay, so there's an example of SAS. Like I said, we'll probably hit all of the examples in these 5 examples that I'm going to show you guys right now. Okay, and if I'm going too fast, forgive me. I just want to make sure that I get through the video in a timely fashion. Okay, so next one, again, we're going to see if these two triangles are similar using one of the 3 postulates. If we can't use any of the 3 postulates, then of course we can't prove that it's similar. We just don't have enough information, right? So again, let's go through what we need to have in order to use these postulates. AA, we have to have two of the angles, okay? Here, according to the drawing, or to the diagram, we only have one of the angles, okay? But if you remember, when you have angles that are opposite of each other, those are called vertical angles. Those are automatically equivalent to each other. They're congruent, okay? That's going to help us in determining triangle similarity, okay? So this might be a possibility, but let's double check the other two just to make sure. SSS, we need at least, well, not at least, we need all three sides for both triangles. Notice we don't have any of the sides, so SSS is not going to work for us. Side angle side, same thing here. We need at least one angle, and we do have that, but we also need two sides, and we don't have that here. So SAS, we're going to go ahead and determine we're not going to use that one. So let's go back to AA and just make sure that we have everything that we need to make a final statement of whether they're similar or not. Okay. All right, so 72, 72, that's one of the angles. For sure we have one of the angles taken care of. Now, we don't know the measurement or the degrees of angle U. The only thing we do know is that they are congruent to each other, and that's all we need to know, is that two of the angles are congruent to each other. Okay, so in this case, we're going to go ahead and say that, yeah, we have the other A as well, which means that angle S and angle W are also going to be congruent to each other, simply from the fact that we know that two of them are already congruent, and we can assume that the third one is. That's how this postulate works. Okay, so that would be your answer for this example here. Okay, so they are similar due to the AA similarity postulate. All right. Okay, moving on. Let's go to the next example here. There we go. Okay, so in this example, we have angle, angle. Let's see if angle, angle will work for this example. Okay, we need to know at least two of the angles. We know that one of them, one pair is congruent for sure. Angle H and angle A are both 38 degrees, so we know that those are congruent. We don't know anything about these two. We don't know anything about these two. The way they're drawn, we can't really assume anything else other than just those two angles. So angle, angle is not going to work for us. Okay. Side, side, side. We need all three sides. If you notice here in this first triangle, we're missing side KD. And in this triangle, we're missing side EB. So that's not going to work for us. Okay, we need to know all three sides. So more than likely, we're going to test using the SAS postulate. Okay. Now again, anytime you use the SAS postulate, the one thing that you have to be careful of is that that angle that you're using has to be included in between the two sides that you are testing. It's kind of all in the way it's written also. Notice that the A is first. It's not SSA or ASS. It's SA with A in the middle, S. Okay, A has to be included in order for this postulate to hold, for it to work. All right. How do we know if it's in the middle in the drawing? Well, look at the two sides that we do know. We know side DH and we know side KH. Notice how they're both kind of like pointing to H, angle H. If that's the angle that's common between these two sides, then that angle is included. So that holds for SAS so far. Okay, look at the second one. Same thing here. Side BA and side EA both point to angle A. Angle A is included. It's in between those two sides. So let's keep going. We can definitely use the SAS postulate in this example. Okay. We know for sure that the angles are congruent, so we already have the A part. We just have to prove the S parts. Those are the sides, and with sides, of course, to check for similarity, they have to be proportional. And that just means that the two fractions that you set up have to be equivalent to each other. They have to be equal to each other. So the same thing, I'm going to go and set up fractions for just two fractions. Okay. Again, numerator will represent one of the triangles. Denominator will represent the other triangle. Okay, I'm just going to go from left to right in this case. That makes more sense to me. Okay, so the left triangle will go on the top, and I'm going to go in ascending order because that's how I'm going to stay consistent with how I do these problems. That means that I'm going to pick the the lower number of the two, between 20 and 15. 15 will be the smaller number. 20 is the larger number. Okay, so that's in ascending order from least to greatest. All right. Same thing here. The denominator will represent this triangle over here on the right. I'm going to look at the two values that I have here, 28 and 21. 21 is the smaller value, so that's going to go first. 28 is the larger value, that will go second or last. Right? Ascending order, 21 to 28. So let's go ahead and check our calculator and see if they are congruent or equal or proportional. Okay, so first fraction, according to this, is 15 over 21. And that's going to equal, well, hopefully it equals 20 over 28. Okay, hit enter. That's a true. So these two triangles are similar by SAS, the SAS postulate. Okay, so if this was your, for example, something you were working on your assignment, that's the option you would choose. Okay, remember your assignment this week, very similar to last week. It's going to have 4 options. The options will be angle, angle, side, 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 angle, side, and then of course the fourth option. If none of those work, it's going to be not similar. Okay, you just simply don't have enough information to make a decision if it's similar. So you have to say it's not similar, if that's the case. Okay, so far we've seen SAS, 2 SASs, and 1 angle, angle. All right, just 2 more examples, and then we'll be done with the lecture for this week. Okay, here's the 4th example. Okay, I don't know why it's doing that. Just gonna have to hold the paper here. Okay, in the 4th example, okay, same thing. Look at the way it's drawn. All right. Before I start going through here, I'm gonna go ahead and say, you know what? I know that these 2 angles are vertical angles, so I know that they're congruent with each other. Okay, and that's gonna help me determine which one of these is going to be the best option to go with. All right. Angle, angle, we need at least 2 of the angles. We have 1 of them, but we don't know anything about these 2 angles. So angle, angle is going to be out of the question. Okay. Side, 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 we need to know all 3 sides of both triangles. And if you notice here on the first triangle, we don't know side KL, and on the second triangle, we don't know side GH. So because of that, we won't be able to use the side, side, side postulate. Okay. So more than likely, it's going to be side, angle, side. All right. Side, angle, side again, that angle, the A, has to be the included angle in between the 2 sides. All right. So if you look at this first triangle, side KJ and side LJ point to angle J. Angle J is in between, so that'll work. On the second triangle, side GJ and side HJ both point to angle J on this side. And this angle is included. It's in between the 2 sides. So we can go ahead and keep going ahead with the SAS postulate and see if it works. Okay. First thing you want to check is the angle. Are the angles congruent? Yes. They're vertical angles. Both angles are congruent, so we have that for sure, for sure, for sure. But now we need to check the S's. Okay. Are the S's, are the sides, are the ratios that we set up, are they proportional to each other? Are they equal to each other? Okay, sorry. I had a little brain fart there. All right, so if that's the case, if I'm going to be testing 2 different sides, I'm going to set up 2 fractions, okay, 2 ratios, right? What makes sense to me here is I'm going to just go left to right. This left triangle will represent the top part. This bottom triangle will represent the bottom. I'm sorry, this triangle on the right will represent the bottom triangle, the denominator. Okay, how do I know which values to use? That's where I'm going to use the ascending order, okay, from least to greatest. So this first triangle, I'm going to look at the 2 values that I have available to me, 87 and 95. 87 is the smaller value, so that's going to go first. 95 is the bigger one, that'll go last. Okay. Same thing with the second triangle, that's going to go down here. I'm going to look at the 2 values, 68 and 72. 68 is the lower number, so that'll go first. 72 is the larger number, so that'll go last. Okay. Again, this is really easy to mess up if you don't follow those consistencies of, picking an order. You can do descending order if you want, but to me, I'm just going to use ascending just because that's how my brain works. Okay, your brain may work a little different, and that's okay, just as long as you stay consistent. All right. Okay, so let's go ahead and check to see if these two are proportional. Okay. First fraction, 87 over 68. 87 over 68. See if that is equal to 95 over 72. Okay. You'll see here that that's a false statement. These two equations are not equal. That means that this triangle is not proportional, which means it's not a similar triangle. Okay, so we'll say, all right, these are not equal, they're not proportional, so SAS won't work. We can't prove it with SAS, and since we can't prove it with any of the three postulates that are used for similarity, we're just going to simply say we don't have enough information, and we're going to deem these triangles not similar. Okay. Easy enough. You'll have, of course, several examples like this on your assignment this week. Okay, last one. All right. Again, just going through what we need to use each of these postulates. In this postulate, we need angle, angle. Okay. Now, according to this picture, the only thing that I can assume that the angles are congruent is going to be angle R. Okay. Angle R is the same angle for the small triangle as it is for the bigger triangle. Okay. So obviously that angle is going to be congruent. But we need a second A to use this postulate. Again, we run into that problem where angle P and angle S look like they could be the same. Angle Q and angle T look like they can be the same. But since we don't know if these two lines are parallel, we can't assume that these two angles are congruent. Okay, so we don't know any more information about the other two angles. So the AA postulate we won't be able to use. Okay, side, side, side. For side, 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 we need to know all three sides of both triangles. Okay, so the small triangle, 35, 25, 30, check. The bigger triangle, 35 plus 14, 35, and 12 plus 30, check. So we have all three sides. Okay, so more than likely it's going to be side, side, side. You could also use side, angle, side, but in this case, since we haven't seen an example of side, 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 let's go ahead and go with this one. This possibly could also be the right answer. And if you have a question like this on your assignment, which I don't think you do, of course, you could pick either one and they'd both be correct. But for this purpose of this example, let's go ahead and just stick with side, side, side since we haven't seen that in this week's examples. So I'll go through that real quick. Okay, so for side, 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 I'm going to set up three different fractions. Okay, same thing though. One of the triangles will be represented in the numerator. The other triangle will be represented in the denominator. Okay, now which one do I pick for the top? Which one I pick for the bottom? It's up to you. Okay, just stay consistent. I'm going to use what my logic tells me to use, and that is the smaller triangle will go on the top, the bigger triangle will go on the bottom. Okay, easy enough. So here's a smaller triangle right here. Look at the three values of the smaller triangle, and that's how I'm going to determine the order that they're going to go in the fraction. They're going to go in ascending order. To me, that's what makes sense from least to greatest. So between 25, 35, and 30, 25 is the smaller of those three numbers. Okay, what's left over, 35 and 30, which one is the smaller of the two? It's going to be 30. That'll go next. And then the last one, which is the biggest number, will go last. Okay. Same thing with the bigger triangle. The only thing is we don't know the whole distance here, but we know sum of the distance and then the other part of the distance, so we can add these two values together, and that's going to get you 49. 14 plus 35, yep, 49. That's from here to here. Okay, and then same thing here, 12 plus 30, because we don't know the whole thing, we just know some of the distance and then some of the other length. All right, so 12 plus 30, that's going to give us 42. Okay, that's from here to there. All right, so those are the three numbers we're going to look at: 35, 49, and 42. Oops. Okay, so which one is the smallest one of these three numbers? 35, 49, 42. It's going to be 35. So that'll go here. Okay, of the two that we haven't used yet, 49 and 42, what's the next biggest number? Or the next, well, I'm sorry. What's the smaller of these two? It's going to be 42, so that'll go next. And then what we haven't used, of course, is 49. Okay. Ascending order from least to greatest. Let me just double check that because I have made that mistake before on the videos. 42, 49. Okay, looks good. So now let's go ahead and test that. If they're equal to each other, that means they're proportional and that we can say that those two triangles are similar to each other. Now, in the calculator, we can't put two equal signs in the same equation. So we're going to have to do it one at a time. Okay, we'll do this one first, see if they're equal. If it is, then we'll go and continue and do these two next. Okay, so let's try that out. Okay, control division sign to get our fraction. Our first fraction is 25 over 35. 25 over 35. And see what that is equal to 30 over 42. Okay, so that's true. So we're halfway there, all right? For sure, these two are equal to each other. That means they're proportional. So now let's go ahead and test this last one. You can test the last one with this fraction or with this fraction, since they're both equal to each other. To make my life easier, I'm going to test these two together so that I can just delete the one in the middle and then replace it with 35 over 49. Okay, so up, enter, so that I can copy and paste. And now I can change this to 35 and change this to 49. Okay, that's our last fraction, 35 over 49. Okay, hit enter. That's also true. So for sure we can say that these two triangles are similar using the side postulate. Okay, and that's it. That's our last example. Again, just 5 more examples of basically everything we did last time. Okay, this is just more practice with determining triangle similarity. All right. Let's see. Okay. Hopefully, you guys, if you have questions, you can come to class, come to our video conference if you have questions. I'll be more than happy to help you out with that. And again, don't forget, I'm going to be opening up everything for you guys, and everything will now be due on the last day of school, May 22nd, 11:59 p.m. Okay, you have until then. If you haven't done anything up until this point, now would be a good time to get on that. Okay. All right. Have a good week, guys. Hopefully, I'll see you guys in class. Or if you need anything else, shoot me an email. Wrestling shirt of the day, Kevin Owens. Too sweet me, baby. Woo! We'll see you next time. Take care, guys.